had no idea it was supposed to be there. It was creepy. Because I didn't know which one. Alright, let's get this ready. Alright. Really, only two things we didn't talk about in this section. And I think we've talked about this before, right? Maybe on that last, remember on the last test, we had to go over that question, like it said, like sine of 34 degrees equals cosine of what? And we figured out that complementary angles, sine and their cosine are the same if they're complementary. Well, this is the formula for that. Cofunctions says if u is a real number, then if you take the cosine of pi halves minus some angle, it will always equal the sine. Sine and cosine go together. Tangent and cotangent are cofunctions, which means that complementary angles are going to be the same, and secant and cosecant. So they did this in terms of radians, but we could also do it in terms of degrees. So an easy example of that, before we actually do the example, is if I said the tangent of 20 degrees, we'll just do degrees because it's easier to think about. Since tangent and cotangent are what go together, tangent of 20 degrees will be the same as cotangent of 70 degrees. And how did you get 70? Because 70 plus 20 add up to 90, or in terms of radians, the two angles that add up to pi halves. So what kind of questions are they going to ask you on your homework about this? They're just going to say express as a cofunction of a complementary angle. So they're going to give you tangent of pi 6. And they know that adds up to pi, right? That's supplementary, not complementary. So you could say tangent of pi 6 is going to equal, and find this, tangent of pi 6 would equal cotangent of pi halves minus pi 6. You see how I'm just using this exact formula up here? Or figure out what's the complement of pi 6. But really, you're just going to take what is pi halves minus pi 6. Get a common denominator, but I think it's just pi thirds. Is that true? 30 degrees, 60 degrees. So we could say that this is the same as cotangent of pi thirds. That would be the answer that I want you to give me. So sometimes it's going to be in radians. Sometimes it's going to be in degrees. So what if I said, find the cofunction here, secant of 17.28 degrees. And some of the ones on the homework do decimals. Some of them do the degrees, minutes, seconds. Remember that on the calculators, there's that degrees, minute, second button, so don't freak out about that you can just convert it. But how do I know what to do? The big thing that you need to know is which ones go together. Secant goes with cosecant. So this would be equal to cosecant of, am I going to take pi halves minus 17.28? Because I'm in degrees, I'm going to take 90 degrees minus 17.28 degrees to get my answer.
Are these seriously like problems?
These are problems from the homework. I mean, I just picked different ones to give you. But this is the easy part, okay? Hopefully the easy part.
I was going to say, this is super easy. We have like all of our principles?
No. I don't know why I kept that in parentheses, but whatever. That would be the same as saying cosecant of 72.72 degrees. Again, you need to know that secant and cosecant go together, and then you need to know that you're just subtracting from 90, which again was kind of on the last test, but we didn't have these formulas given to us. The other thing that I wanted to pick out from this section, maybe because I saw it on a future quiz or test for you, is using those sum and difference identities given a value. So look at this next one. And you kind of might want to write small under part A here, or you might have to go to the back because I kind of had to squish it in there to get this done. But it says, suppose that sine of alpha equals 4/5 and cosine of beta equals negative 12 over 13, where A is in quadrant 1 and B is in quadrant 3. Find the exact values of sine of alpha plus beta and tangent of alpha plus beta. So the difference between what we did with these formulas before is before they actually gave you an angle, right? Like find the sine of 30 degrees plus 45 degrees, and you actually could break it up. Now we're going to give you values. So they're going to make you go back and think about where am I? Could I draw a triangle? What would the missing side be? And use stuff that way. So step one on this is let's kind of sketch out what we have, maybe off to the side somewhere. I'm going to just draw it over here. And let's just start with alpha, right? Two separate angles here. Sine of alpha, they tell us that we're in quadrant 1. That's important because sine's positive in two quadrants, so you have to figure out which one you're in. If this is in quadrant 1, Do you agree that there's some angle here, alpha? Like that would be like the point that we could draw the triangle in. And the sine is opposite over hypotenuse, so it would look like that. Remember doing that? We can't use unit circle stuff here because it's definitely not a hypotenuse of 1. But what we could do is we could do Pythagorean theorem to find this missing side. You with me on that? Or do you know which missing side goes with sides of 4 and 5? Do you know that triangle? I'm just going to tell you. It's 3. 3, 4, 5. Always goes together. If you didn't know that, you could take a squared plus 4 squared equals 5 squared, and you would get a squared equals 25 minus 16, a squared equals 9, and you still get 3 there, right? But 3, 4, 5 is the right triangle. Which means if I wanted to find any trig value of alpha, you could tell me what the tangent of alpha is, or the cosine of alpha, right? Like you could say cosine is 3/5, tangent is 4/3. Yes? That's why we need to draw this picture, because we're going to need that in a minute. So, what else do we know? Cosine is negative 12 over 13, and what quadrant are they telling me that beta's in? Quadrant 3. So that means somewhere down here in quadrant 3, I'm going to draw in that reference angle and call that beta. It doesn't really matter how you draw it, but I'm just going to put beta right here. It's a very squished beta. But use what they give me. Cosine is adjacent, so that would be negative 12 over hypotenuse, that would be 13. And again, doing Pythagorean theorem, could we figure out what y is going to be? Since I'm in quadrant 3, do you agree that y is going to have to be negative? And again, let's just kind of do that in our head. What's 13 squared? What's 12 squared? 169 minus 144, 25, square root 25. I just know it's 25 because I also know 5, 12, 13 is a triangle that goes together. Those are like the 2 triangles I know. 5, 12, 13, 3, 4, 5. I don't know why I know that, but I know it. I've been it 1,001 times. Okay, so on these questions, draw your picture. Now let's use the formulas. So let's forget about tangent for a minute. Do you remember the formula for sine of alpha plus beta?
You said sine and cosine.
So it's sine of alpha, cosine of beta, right? Like you take the sine of one times the cosine of the other, plus, then you switch it. The cosine of alpha times the sine of beta. And instead of actually having to use like your unit circle to find values, we're going to use the triangles up here to find these values. So it's important that you label your triangles correctly. But I already know the sine of alpha, right? They gave it to me. So can I just replace this with 4/5? Everybody with me on where I'm getting that? 4/5 right here. Or I could use my triangle opposite over hypotenuse. Cosine of beta, also already know, negative 12 over 13. But the second part here, cosine of alpha and sine of beta, that's where you need the triangle. Cosine of alpha. Cosine is adjacent over hypotenuse. So is that just 3/5? And sine of beta is going to be what? Negative 5/13. Because there's beta, opposite over hypotenuse. Y over R. Then you can just work that out, right? We're done with the trig at this point. It's just simplifying. You're allowed to use a calculator. You can just use the fraction button. So here we go. Do you use a calculator? Except for Angel. Look, I was tipping you over so you could reach it. I was going to hold you up.
Oh, scared?
I don't know what 5 times 13 is. I just typed this in all at once on my calculator. Like, use those fraction buttons, and you can do it all at once. 4/5 times negative 12/13 plus 3/5 times negative 5/13. And I got negative 63 over 65. Did you get that? Like I just did it all once on my calculator. Because negative 48 minus 15, I'm guessing, is...
Oh, hey, Miss Dixon, I really need to tell you something. You would have been so proud of me yesterday. I went to tutor these little kids in math, and one of the kids that I was tutoring had to teach me half of the packet, and then I had to teach them.
Why would I be proud of that?
I'm being sarcastic. It was really fun. She had to teach me how to do that. Because it was like 4 3/5 plus 5 and 2/9.
Please don't talk to me. So, I forgot, we're not done yet. We also need to do tangent. And so we're just going to use that tangent formula. Do you remember the tangent formula?
Yes. Tangent of A plus tangent of B over 1 minus tangent of A. Look at that.
So then you just plug that in. This is the type of question that's on your test from this section. And so then you have to use your triangle to find the tangent values. And again, we can use our calculator to help us compute them. Tangent of alpha is going to be what? 4/3. Right? Tangent is y over x, or opposite over adjacent. And tangent of beta is going to be a positive number because we're going to get negative 5 over negative 12, which is just 5 over 12. And then on the bottom, it's the same numbers, just now it's 1 minus them multiplied together. This is where if you use your calculator, I'm okay with it. I actually showed a little more work on this one because I did the top and then I did the bottom separately. But as long as you show me this step and then you show the answer, I'm okay if you do it all at once. But on the top of that, maybe we should do this by hand to show Aaron how to add fractions.
No. I did.
You get step number 4. Do you all know how to make your calculator give you an improper fraction as opposed to a mixed number? That's because you got fancy. If you hit second fraction button after you get a mixed number, so do 21 fraction bar. Right? So like if you do that, you do the fraction bar, it gives you 1 3/4. But if you want a mixed number, you just hit second and the fraction button again. So 1 minus 4/3 times 5/12 gives you 4/9 on the bottom. And so then you can just do that on your calculator, or you can flip it up, and if you flip that up, that would become times.
Keep it, change it, flip it.
So if you multiply it by the reciprocal, I think you get 63 over 16 as your answer. Do you not get that? 63 over 16. So it says give the exact values, which means, no decimals, I think. Even though the decimal's exact. We like fractions better. Trying to get you there. So now part B says find what quadrant contains alpha plus beta. We only know what alpha plus beta is, but this is a really easy thing to do once you do it once. Well, the sign of alpha plus beta, alpha plus beta, was negative 63/65, yes? So do you agree that I could say the sign was negative, sign was less than 0? And the tangent of alpha plus beta was positive 63/16, yes? What quadrant do you have to be in if the sign is negative but the tangent is positive? Does that make sense of how you can figure that out? So don't overthink it. Like the first time I saw that, I was like, am I going to have to like sketch this and think about if I add them together where it would be? No, you just look at the signs of what they asked you to find, and then figure out what quadrant you're in. That's the majority of your homework today. We'll see what questions we have. Make sure you pay attention to what quadrants they tell you that you're in so you can draw your picture. But definitely there's questions like this on your test for this chapter, and I'm guessing on your quiz. I haven't looked at it yet. But that's it for 7.3, and then we'll start 7.4 tomorrow. And you only have this many questions, but kind of very funny. I think there's